Good evening, students. Today in our series of lessons we are going to do part 3. As you all know that in part 1 and part 2 we did about series and parallel circuit, about the arrangements and how the current works in series and parallel circuit, and after that in part 2 we discuss about parallel and series circuits total resistance, that is the effective resistance. Okay, today we are going to discuss, as I told you in the previous lessons, questions in page 47 and 48, which I hope you all have tried, and the idea of today's lesson is to give you the solutions so that you have sincerely have done and can now check your answers. The next lesson will go into another subtopic. So today is our part 3. And just to recapture what we have studied in our last lesson, in series circuit we talk about current, resistance and also the voltage. So in series circuit the current is the same, no matter what is the value of the resistance. Okay, I1 equal to I2 equal to I3, this is for the current. Whereas for parallel circuit the current is no longer the same, but it is the sum of current in each resistor, I1 plus I2 plus I3. Whereas for voltage, it is the sum of voltage across each resistor, V1 plus V2 plus V3. This is based on 3 resistors. Okay, and for voltage, for parallel, they are the same. Okay, V1 is equal to V2 is equal to V3. Okay, this is what we studied about voltage and current. Talking about resistance, the total resistance in series circuit is the same of every resistor, that is effective resistance is R1 plus R2 plus R3. And then for parallel circuit, you have to take the reciprocal of the resistance, that is 1 R1 plus 1 over R2 plus 1 over R3. Okay, so this is what we are going to use to solve the questions in page 47 and 48 in today's lesson. Okay, if you look at the first question, it is A, the total resistance is quite simple. It is in series. As you can see, there are 3 resistors here, I1, I2 and I3. So I1 is 20 ohm, I2 is 10 ohm, and R3, sorry not I, R3 is 5 ohm. So the total resistance, simply you just have to add R1 plus R2 plus R3, that is 20 plus 10 plus 5, so you get 35 ohm. That's all. And if you look at the second one, it is pure parallel circuit. That is, look, they are given 3 resistors here in parallel. Okay, 3 resistors in parallel, and each resistor, the value is 8, 8 and 8, 8 ohm, 8 ohm, 8 ohm and 8 ohm. So the total resistance, we apply the sum of total resistance, that is 1 over Rs is equal to 1 over 8 plus 1 over 8 plus 1 over 8, which we get 3 over 8, but we want to find the total resistance Rs, so therefore it is 8 over 3, which will give you 2.67. Okay, we can work from your calculator. So this is the answer for the first A, B, and now we are going into question C. C. Okay, let us see the C now. Okay, in question 3, that one C, okay, the third question, it is given as 2 series resistors. Okay, each value 10 and 20 ohm, 10 and 20 ohm, and then we have 2 resistors here, 8 ohm each. Okay, 8 ohm each, 8 ohm and then 8 ohm. And these 2 parallel, but they are series to this, series, and then they are series but they are parallel. So therefore, we have to get the equivalent resistor for series, all series. That means it is something like this. Okay, 20 ohm here, 10 ohm. These 2 8 ohm we have to find as one effective resistance for parallel, for these two. Okay, so therefore you have to calculate the parallel separately first. That is 1 over R parallel, 1 over 8 plus 1 over 8. We get 2 over 8, that is 1 over 4. Therefore parallel is equal to 4 ohm. So therefore what we get here is 4 ohm. That means these two 8 ohm become now 4 ohm already. So therefore the sum of all the resistance now is in series. So we just use series formula. That is 10 plus 20 plus 4, whereby you get 34 ohm. So that's simple as that. So when you have in parallel, that is to series, you have to solve this first, then only you got to add. Okay? Alright. So now we move on to the last question of the first part. That is 1D. 1D. Okay, if you look at this circuit, it is parallel. All the resistors are arranged in parallel, but in this parallel we have series. Okay, so as you can see here, okay, right. So this is the circuit given. Okay, this is 8 ohm, this is 8 ohm, this is 8 ohm as well. Okay, and these two 4 ohm and 4 ohm each. So to solve this is quite easy. What we do, we try to get the equivalent circuit first. This 8 and 8 is making up as 16 ohm because they are in series, right? They are series, so it becomes 16. And this is 8, there's no change about it. Okay, still 8 ohm because it's a single resistor. And then these two 4 making up another 8 ohm. Why 8 ohm? Because they are series. Just add up 1 and this, so you get 8 ohm. Okay, now we have all the 5 resistors here. Now we make up into 3. And these two become 1 equivalent. This is 1 and this is. So therefore, now the solution become for parallel circuit is 1 over 16 plus 1 over 8 plus 1 over 8, which will give you here 2 and 2, 2 and 1 is 3, 2 and 2 is 4, 4 and 1 is 5. 5 over 16 times 2 times 2. Okay, so therefore the effective parallel is the effective resistance. Okay, we write it as a sum of resistance RS. So it's going to be 16 over 5, which will give you 3 times 5 balance 2. So 1 is 3.2 ohm. Okay, so this is how we solve the series and parallel circuit, the sum of it. Alright. Okay, now we are going into more difficult question, that is applying the series and parallel circuit idea of voltage and resistance. The following question, the question 2, 3, 4 are a bit difficult in the sense that they are including the concept of potential difference and current in this circuit together with the series and parallel resistance. Okay, now let us look at that, how is to do it. Okay, so you can refer question 2. Okay, question 2, 3 series circuits with a supplied voltage 8 with 3 series resistors. Okay, 3 resistors, that is 2 ohm, 4 ohm, and then the last is 8 ohm. Alright, this is R1, this is given as R2, and then this is given as R3. Okay, and they also place a voltmeter. This is voltage V1, voltage across here is V2, and then voltage across here is V3. Okay, alright. So the question asks, calculate the effective resistance R of the circuit. So we have 3 resistors here. So the effective resistance, that is the sum of resistance, we just add up to answer the first part. A is 2, 4 and then 8, 6 and 8. 2 plus 4 plus 8, so you get 16 ohm. Okay, alright. Now question B. Question B asks to find the current in the circuit. That means this is the current, that means the main current. As you know that the current in series, no matter where, is the same. So therefore this current I is for the whole circuit, which is same everywhere across the circuit, as we already mentioned here earlier. So we just find the total current. So total current is given by total voltage over the total resistance. This is based on your Ohm's law. You have to apply our Ohm's law here. That is V equal to IR, right? When the temperature is constant, so we can apply this. So therefore, 8 ohm divided by 8 voltage divided by 16 ohm, right? So you get 0.5 ampere. Simple as that. Okay. So now they ask, what is the voltage V1, V2, V3? Remember the current, same current passing through every resistor. So therefore, voltage is given by current times by resistance. Therefore, voltage V1 is current times by resistance I1, R1. The same current. So, current we already got 0.5 times by resistance 2. So, therefore, we get 1 volt. Then V2, same it goes. The same current, 0.5, but multiply by the resistance here, that is resistance 0.5, current 0.5, resistance is 4 ohm, so therefore we get 2 volt. And finally 0.5, the same current multiplied by the resistance 8, so we get 4 volt. Okay, 0.5 times 2, 0.4. Okay, so we get here 2, 4, 6, 8, 14, 16 ohm. 16, 8 divided by 16, 8 volt divided by 16, so 0.5. 0.5 times 2 is 1, 0.5 times 4 is 2, 0.5 times 8 is 4. Okay, so sorry, I think this is not very clear. This 8 ohm, 8, 4, 2. Okay, so we get all in 7 volt, 7 volt. But the supplied voltage here is 8. By that you should get, if you add up all the 3, you should get 8. So there is some error here in our calculation. Maybe you can have a look again, review. 2 times total voltage, total this is 2 and oh sorry, I made a mistake, excuse me. 2 plus 4 is 6, 6 plus 4 is 8, 14, correct. So 8 over 14, yeah? So sorry for about it, okay? So we have to redo it because the current value, I made a mistake. The current is 8 over 14, which we will get as 8 divided by 14, that is 0.57. Yeah, 0.57 ampere. 0.57 ampere. So therefore, we recalculate 0.57 times by 2. Here 0.57 times by 0.57 times by 4, and then 0.57 times by 8. That's right. Okay. So 0.57 times by 4, you will get 2.28. 2.28. 2.28. Here 0.57 times 2. 0.57 times 2, you should get 1.14 volt. This is volt, and then 8 times 0.57, you should get 8 times 0.57, you should get 4.56. Yeah. So if you add up all these 3 voltage, okay, across here, you must be getting 8. Yeah? Of course, let us add and see. V equal to V1 plus V2 plus V3. This is just to check. Okay, this is just to check because whether our calculation is right or not. So V1 is 1.14 plus 2.28 plus 4.56. Okay, if you calculate, of course you won't get exactly 8. 1.14 plus 2.28 plus 4.56. So you get 7.1, okay, 0.57. 0.57 times 4, 2.28, 0.57 times 8, 4.56. 4.56 plus 2.28 plus 1.14. Yeah, you'll get 7.98 volt. Okay, so this is 8 volt. Why we are not getting 8 exactly? Because when you divide this value, we already omitted the rest of the significant figures. Okay, we only rounded it to the nearest two significant figures. Therefore, we got it as 7.98. Then, if you take more decimal places, of course, we'll get exactly 8 volt. Okay, which is this is if we round it, of course, you will get as 8 volt. Okay, so that's how the solution for question 2 goes. Okay, let us now look at the third question. I hope you have tried. Okay, as I have been telling, this lesson, this series of lessons, we need your cooperation to try out. If you just wait for my solutions and you just copy it, I don't think you can make any learning. Okay, this I have been telling in the class also. Okay, number 3, if you look at question 3, we have 12 volt here. Okay, we have 12 volt, whereby we have two resistors, each making up 8 ohm and 12 ohm. This is 12 volt. Okay, and then we have that. Okay, so they want what is the potential difference across here. That means they want what is the potential difference across 8 and then the potential difference across 12. Okay, so here they never ask you to find the current, but earlier question they guide you already find the current. Okay, so if you want to get the voltage V1, since this is a series circuit, as we already said, current is the same. Alright, so V1 will be I times 8 ohm and V2 going to be I times 12 ohm. So you want to find the what is I first. So I is the total current. So you take the total voltage divide by the total resistance. So total resistance you can get 8 plus 12 is 20 ohm. So therefore 20 voltage is 12 divided by 20. Alright, 12 divided by 20, so you will get 0.6 ampere. Alright, okay, so therefore simple now, I is 0.6 times 8, then you get 4.8 volt. Then here I is 0.6 times 12, so you get 7.2. Okay, you get 7.2 volt. Okay, so when you add up 7.2 and 4.8, you will get your 12 volt series. This volt plus this will get the total supply voltage. Okay, now let us move to the last question for the day. That is the fourth question. It is a parallel circuit. Parallel circuit is given as this. The supply voltage is 6. We have 3 parallel resistors. Okay, each value is different. Okay, they have different values for all the resistors. That is based on the question. This is R1 as 2 ohm, R2 as 4 ohm, and then R3 as 6 ohm. Okay, right. So what they want now? The potential difference across each resistor. So for question 1, you don't need to find any potential difference. No need to find simply because for parallel circuit the voltage is the same. So question 1, they ask what is the potential difference of each resistor. It is basically, if we say V1, V2, V3, all are equal, which is equal to V, which is 6 volt. So answer for question A is just 6 volt because they are parallel circuit. For question B, they want to know what is the effective resistance R of the circuit. So effective resistance, they are parallel. So 1 over 2, 1 over 4 plus 1 over 6. So what we get here, the total resistance, we just work out 1 over 2, 1 over 6. So we do it in fraction, it's easier. 2, 4, 6, the common denominator will be 12. 12, this will be 6. This will be 3. This will be 2. So we get 9, 11 over 12. That is, the effective resistance RS is going to be 12 over 11. That is 1.11. 12 divided by 11. So you should get 1.09. 1.09 ohm. This is the effective resistance. Okay, just recheck. 0.5 plus 0.25 plus 1 divided by 6. So you should get 5 plus 25 plus 1 divided by 6. So you get this. So 1 divided by answer. Yeah, it's correct. So 1.09 ohm. So that answers the B. Okay, now the C, current in I. Okay, current I. Current I here means the main current they are asking. Okay, why I say current I? If you look at the diagram, it's also given. And over here is mentioned as I1, here I2, and here is I3. Okay, alright. So for I1, so for current I is the main current. So main current, we take the main voltage divided by the effective resistance, because this is the main current which is passing through all the resistors. So therefore, we can work it out. 6 divided by the resistance, we already got it, 1.09, which you will get as 6 divide, okay, so you get 5.5, right? So you get 5.5 ampere. Okay, this is the total current that is passing through the whole 3 resistors. Okay, after which it's already going to split, but here is the main current. Okay, so now they are asking what is the individual current. So for individual current, it's easy because this is a parallel circuit. So when you have a parallel circuit, the voltage is the same. So therefore, nothing to worry. They just take I1 voltage over the R1, because voltage is the same one, right? For parallel circuit, voltage is the same. So 6 divided by 2, there you get 3 ampere. Then I2, the same 6 over R2, that is 4. 6 divided by 4, you get 1.5 ampere. And then the I3 is equivalent to 6 divided by 6. So you get 1 ampere. So if you add all the 3, 3, 1.5 plus 1, you will get 5.5. I don't know, because I1 plus I2 plus I3, based on our parallel circuit idea of current, the total current is equivalent to the main current, right? So it is just to check, right? 3 plus 1.5 plus 1. So you will get your 5.5 ampere. Okay, this is just to check, right? They didn't ask the total current to verify, but we are just verifying based on our calculations. Okay, so that solves the problem of these 3 questions. Okay, now if you look at page 49, alright, so page 49, question 5 and 6, they are more difficult questions because now they are already combining parallel and series resistors in the circuits. Okay, please look at page 5 and page 6, sorry, page 49, question 5 and 6. So what I want you to do is, please try out this question. Okay, so in the next class, in our part 4, today is part 3. So in our part 4, I will go through this question, which is more difficult questions, and then we are going into another new concept called electromotive force. Okay, electromotive force and internal resistance. Okay, electromotive force and internal resistance is a concept of voltage and resistance and also current, considering a resistor in a battery. Okay, so far what we have been discussing is we assume this battery has no resistance. Actually, battery, as you all know, it is a chemical inside. Okay, there are some chemicals inside to make your electrolysis process. So once there is electrolysis process, you all have learned in chemistry, anion, cations and all that. Okay, so there is some resistance within the battery. So when you consider the resistance inside the battery, that we call it as internal resistance. And then the voltage that is supplied by the battery when it comes to external resistors is no longer the same. Alright, the battery will indicate, but outside when you measure the voltage, it will be slightly lesser than the actual voltage given by the battery. Okay, so this concept is a bit abstract, and in the notes they will use about 4 pages to explain this, but it's actually just to clarify in very detail, but actually we can put it in a very simple way by understanding some of the basic ideas about the battery and their resistance, so it will become quite easy. Okay, so in our next class, part 4, lesson part 4, I'll be discussing the 2 difficult questions, plus I'm entering into the electromotive force. That is actually the second last topic of this chapter. Then the last chapter will be talking about, the last part of the chapter will be talking about resistance, power and energy of electrical energy. Okay, so with that I end today. So hope you are still having your quarantine time in the house. So take care of your health and your hygienic. We've been hearing in media 24 hours a day, we've been hearing about the hygienic. So please take care of your health. Okay, distance yourself. Try not to go out from the house. Okay, it's already 2 weeks I never step out from the gate. Okay, so that's the life we have now. So hope everything comes normal in very soon. See you then. Thank you. Bye.